start.
Hello, and thank you for being here today in the presentation. It's very unfortunate, but I cannot join today to this event in Taiwan. So, greetings from Germany. I'm sorry that I just pre-recorded things, but I want to tell you more about this way for safe systems constructed by open source software. And a few words about myself. So I'm a senior OSS community manager at ETAS, which is a subsidiary of the Robert Bosch GmbH, often known for household appliances, as a car tier one supplier, or also in other areas of tooling. And so most likely, if you check your car, you find maybe part of it. Then I'm also the LISA project chair of the technical steering committee, and I'm also leading the systems working group. This is also the reason why I'm presenting the things to you today. Just to mention, I'm also an inaugural advisory board member of the Linux Foundation Europe, and I'm open source enthusiast and promoter. In case you want to reach out, there is the LinkedIn part and link, so you get a chance to scan it. I'll also show it at the end. And don't hesitate to reach out. What you can expect today is first a lot of intro and motivation. And then we dive into example open source projects and their approaches to come to safe system construction. A fundamental part will also be the open source requirements tools. A lot of work is done on requirements, many know commercial tools, but there is a huge set which helps us also just open source tooling. And we also want to show and see how the requirements get inside the Linux kernel. And yes, you're reading right. We want to get this into the Linux kernel. Lastly, I have a little bit of summary and a call to action in there. So let's get on. First of all, on the intro and motivation, you can see that when you create safe systems, you typically need to get also safety integrity standard at hand. It could be for mechanical parts, but we're in the SDV track, so it's mainly automotive. It may be the ISO 26262, and then you need to see that these standards were created a long time ago. And it was not really clear at this time how complex the system would be these days. And somehow all the things need to end up with the zonal architecture, centralization of electronic control units, more computation resources, connection to the cloud, and other elements. And therefore, you need a robust fundament of processes, technical measures, and statistical analysis to get an argument that your system has a very low risk of causing harm, and it's so low that it's safe to operate. Furthermore, there is a growing interest by the industry in open source for safety critical applications, which means they would like to speed up in their development, or they can just use it, save money. Many things are there, and it's really hard to get this fast driving world, which is not in the typical development model, combined with standards. So open source and standards is not an easy thing. Fundamental challenges which we see are that the traditional development processes, which are more waterfall, V-model stylish, do not cope with the code-centric open source development. Then we have often standard checklists where you know that we want to tick all the boxes, make sure that everything happened. And then if we put this toward the collaborative development where we work in iterative steps, where the elements may be split, you don't write exactly the one specification, but you have multiple spread things, this makes it complicated. And we also have the need for formal traceability and documentation in safety critical systems, which means all the artifacts need to link with each other. We have this in many places, not the traceability, but the artifacts. But it's really the point, like, how do you get the things forward? And there are three major areas where you see this. And so the passes which you can take in automotive is like on the one hand, the IEC 61508 Root 3S for pre-existing software. This basically means you apply the safety practices on a pre-existing software like you would do for your own software development. So it sounds a little bit like re-engineering artifacts on requirements, testing, architecture, and so on. For simple components, you can go for the ISO 26262 Part 8, Clause 12. This is the approach for automotive applications, but it's really meant for simple parts, so don't put a full Linux kernel or everything in there. The third part, which should describe it a bit better, is the ISO PAS 8926. This will migrate into the third edition of the ISO 26262. And this should be a bridge for the complex software. And as said before, the more complex your system gets, the more challenging things will be. So the challenge will increase with complexity, and Linux is a very complex system. Just once more, to clarify, procedural requirements for safety. You have structured documentation of your requirements. You have the traceability from tester requirements and other elements. You need to keep your documentation synchronized with your code base, and also now you need to achieve maintainability over decades. Right. What are challenges for projects? We have first of all, the argument that the OSS development is not organized like commercial software. You remember the V model and the code-centric development. We have less influence on maintainers. I may spend a few words later on this. And then we also have the harder times to train developers, because we may not know the developers. They are hidden behind GitHub names, Gitty names, whatever you have. Or then also liability. I believe that's the strongest thing, but this opens commercial offers because someone needs to be liable for what you're developing and what you provide. And the community will not be liable due to the license, due to the not availability of the developers, because you cannot find them as a person, and so on. And then the last part is, well, a central part, the development process. So the last two, I think, are the harder things to argue. And at least for the last one, we have a good way of going forward with the example OSS projects, which I'm showing now. So, example OSS project. There are many projects which work on the path of safety certification, which try to bring a product out of it and provide support and all these. But I would like to concentrate on 3 projects. These are all within the Linux Foundation, and it's on the one side the ELISA project, where I'm working in, the Enabling Linux and Safety application. Then we look into the RTOS world with Zephyr. I show that there are alternatives around there as well. And I go in the virtualization hypervisor part with the Xen projects. So, I think if I saw the agenda correctly, there is or was already also a presentation here at the conference about Zephyr. So if you will learn more about it there as well. Briefly showing you the members. This has changed today again. I guess there are new members. For example, the Xen project also welcome Fort these days. So this is a new membership, and we see that also Zephyr gets more and more members. So it just show you like the size of the projects, and you can see that the ELISA project with the Linux base also has a bunch of automotive elements in there. Like we have Aishin, who is also the company where Yamaguchi-san is working in, or for. We have Bosch, which is my company, and then with Honda, Electrobit, EMQ, Nissan, SAIC, Wind River. They have heavy stakes in the automotive space, and Red Hat dominantly would like to get also the Red Hat in-vehicle as promoting it worldwide in Asia and other parts. These were the 3 Linux Foundation projects, and I said there's a bit more. Just to show you 2 parts, there's, for example, the L4RE, which is a hypervisor by current concept. This is continuously developed, used also in automotive, and it has safety parts, but this was considered there from the beginning. And the second one, which you can have right now, is the ThreadX. ThreadX is from the Eclipse Foundation. It also has a safety certification, but it was certified before gone to open source. So which means it was Azure ATAS at Microsoft, AZLT certified, and then brought into Eclipse Foundation, so to continue the open source work there. Now back to Zephyr. Zephyr is targeting safety certification from the beginning, and it will provide safety artifacts and the safety manual, but the certification parts are limited to premium members only. And not everybody will be able to see, so you need to pay for it because it's super expensive to create all this, and by this you should take part of it. The safety working group meets regularly. I have some notes about this later on. And the safety awareness is limited in the community, and because it's so widely used, so widely adopted, it's comparable to the Linux side. You have all the sensors, boards, actuators, chipsets, all is supported, but most use cases are not safety relevant. But the rich ecosystem is really like the player for this, and the POSIX compatibility is also something people like a lot. Xen is a bit different. They started with a security working group long time ago, and they really look on how they handle security, and with their security background and their rigorous quality process and the full commit traceability, CI pipelines and so on, it was easy for them, or easier, to adapt to the safety demands, and they also find a good beckoning in their community. So then Linux is the biggest thing to look at, and I start with the bottom bullet point, which says like open space examples still to Linux MP. This was a project before ELISA was started, and nowadays ELISA basically comes into this field, but ELISA is not creating a product. It has a wide community, and this comes like because Linux is basically the open source software superlative. It has a largest community, largest source base. It's made for all kind of use cases, spread from servers to deeply embedded, spread over all world and even in space. And there were several attempts and certification passes. You can see this on the right with all these press releases which I found. I'm sorry that I don't have something from the Asian region that much, but that's where the ones which I could find easily in the English language space. So, and going forward about the ELISA project, this is basically to enable safety critical applications with Linux. That's what I said. We look in dependability and reliability for the whole Linux ecosystem. This is important to understand because it's not only about safety. It is about dependable, reliable systems. So whatever we do should improve the capabilities of Linux, should make a better Linux system. And therefore we also support it by industrial grade Linux distributors. We saw them on the member page, for example. And we want to do this work not alone, but we have close community collaboration with Xen, Zephyr, SPDX, Yocto, AGL projects, because they are working in a similar domain. And this you can see in the reproducible system which we try to create, where we bring all the different technologies together. Lathe at the yard part, this creates elements, processes, development tools. That's where we really would like to give our results. We are not giving you a safety certified kernel. That's not our intention. We cannot do all the work, and we have some limitations. I would like to show you like a disclaimer slide. This is first what I want to mention. It comes from ELISA. It also holds true for other projects. First of all, whatever we do in the open, we cannot engineer your system to be safe. This means you still have your system understanding, you need to know how the things work, and you need to make sure that you apply things properly. Also, this is true for the processes. We cannot ensure that you know how to apply the described processes and methods. It's your responsibility and understanding. The best understanding you gain when joining the communities around these projects or joining ELISA. And often it's like the idea that we have a baseline version of software, but as you are most likely also in the open source software space, you know that we have a continuous product, we continuously move forward. And that's where we want to end up. So we have continuous improvement, so we cannot just say this is one version and we make this version safe, because then it may not be secure and may have some vulnerabilities, and we need to work on changing the version. And then there are the legal obligations and liabilities. Still, ELISA and the other parts drive a way forward. And you see this by all the members which are working together on this. They are not stopping, but they are trying to overcome some of the limitations. And we are open. So now I will do a little bit of comparison and start with the fully open versus pretty open. We have safety, and safety is cost expensive. So for this, the safety work was first in the premium members for Zephyr. But now, since 2 years already, the safety working group was started and is operated in the open. And it was really live and openness. They discuss about a lot of requirements and so on. The two parts of this bring the thing forward, and they have good exchange every Tuesday night, I guess. But, as mentioned before, some results remain behind the scenes. They are only visible for premium members. So that means that they are open, you can join, you can participate, but if you want to see all artifacts, become a premium member. For the Xen project, they also move on. The discussions are open. You may need to show that you have MISRA C documentation, but even there they made limitations. The thing is, the safety manual and safety artifacts will be made commercially available via AMD and Xilinx, but also other companies could hook on, because Zephyr and Xen project both have an open code base, and this code base is the same code base which is also used for the safety parts. But you need to understand and know how to use it. That's why you should look into the safety manuals and other artifacts and spend most likely the money to get this science. ELISA has nothing like this with the payment model, but as mentioned, we are also not providing a safe Linux kernel. We are just giving you elements, processes, tools. We're doing webinars, seminars, and basically try to give you all the little pieces, all the little things around it to come forward. You can see this some trainings, as mentioned. I start on the right with ELISA, the Linux side. So we have this as webinars. We tell about ISO 26262 new things, IEC 61508, but not as a safety training as such. But we have many safety experts within the project which work in this field since many time, but they are good to be asked for exchange. On the left, as the Zephyr project has a wide adoption in many industries, they go for the IEC 61508 rather than ISO 262 for their training. They train project members, contributors, maintainers. The maintainers have an official safety training, and here the safety committee also mainly consists of experienced safety experts. So this is also a way how to train the people. For Xen, they had MISRA C trainings. This was also important because they want to clean up things, and they have a safety expert also, and with practical product experience, so he can train other parts. One single slide about the financing. Certification financing is done by Platinum members at Zephyr. AMD Xilinx do it for Xen projects, and certification in Linux is done by integrators, not by ELISA, so it's like companies like Red Hat or CodeThink. There's a few more, but that's basically those which work on it. What do they actually certify? And this is important to see the code complexity. So as we have a much smaller upstream code size for Xen and Zephyr, it could be more easy to get this certified. And there's also less complexity for features, like there's no level 2 caches, no dynamic memory allocation. This was actually stripped out in Xen because it was not needed. And also for Zephyr, you may even go for the modularity and get in just some parts being certified. For Linux, it's a completely different thing. Linux has 1 million lines of code. So the integrators, those who build products, have a different approach. There are two main streams in there. The one main stream is about safety allocation to the system, Well, Linux supports the safety allocation, which means the safety is not within Linux, but within the whole system, and Linux operates workloads in an environment maybe observed by a watchdog or different measures. We'll look on this on the next slide. The safety Linux as such means you really put an ASIL safety integrity limit, typically up to B, what I've seen so far, to the Linux kernel. And the three basic concepts which you normally have is that you either have it like safety Linux, safety allocated to Linux. You see there this green little box inside Linux. So here's safety focus, which means there are other parts within the Linux kernel. This is super cost extensive, so you may want to look for, can I fulfill my use case in another approach? So you may end up in this middle field where you put safety monitoring via an RTOS. You go for either SafeRTOS, ThreatX, Zephyr. You may have your AutoSARs built there and put some monitoring in this, and then you monitor the Linux environment. So this would then run and check, doing some CRC runs, whatever, ground truth comparison, what do you have in mind? And the other option could also be to put a safety focus in the hypervisor and let Linux run on a hypervisor like Xen, or also the CARE concept L4V, and then have this monitoring from this side. This can be very helpful because you have more control on the system, but you may lose flexibility and porting. What all these have in mind is that they always rely on a watchdog concept. Somewhere there is a watchdog in the system which observes that everything is scheduled and still running. The watchdog is a kind of challenge response watchdog, and it's a safety net for you for the safety critical workload. And it's widely used in many applications. So there is the eGAS concept with the electronic gas panel acceleration ports. So this is where it originated, and it can be used in an iterative approach. So you can give a lot of responsibility to your RTOS and then give more and more responsibility to the Linux system and reduce the demands which you have on the safety side for your watchdog. I put the link down there, clickable for the eGAS parts. And just one thing which I want to mention, with a proper system design, the watchdog will never need to trigger the safe state. It's a quality thing and a safety thing. So you should make up your mind that it stayed there where it is. Then I made a slide just like for software-defined cars beyond IVI. Linux was used for the in-vehicle infotainment parts, but now we see that it was also in many car ways, like for rear view cameras, for the instrument cluster warning sign and the speed meter which shows your gear. These are called telltales. You may have outside electronic mirrors or surround view, so you see a lot of camera applications already there. And from this there was this, would say, more aggressive move to really put Linux into the ADAS field, into the level 2+ systems, and this is becoming far more mainstream now, right? It is in the development to have this also by conservative players, and you see now that level 4 systems are in development, which may also in the future be a conservative part. Level 3 is a tricky thing because this is cost sensitive, and you will need to see, is it something worse for you? How can you handle things? And this means you need to understand your system. So Linux and safety critical systems means a setting whether a system is safe requires understanding the system sufficiently. You need to understand Linux within that system context and how Linux is used in that system. You need to select the Linux components and features which you believe which are relevant for safety. And then you need to identify the gaps that exist where more work is needed to evaluate safety sufficiently. You may end up with monitoring parts, you may end up with additional testing, writing down architectures and so on. And this is basically because you require certain things. This brings us to the requirements tooling. Open source requirements tools. For Linux, there is the Bazel. Bazel is like a spice from Italy, and it was created by an Italian guy, so that's the reason why it's called Bazel, the Fusa spice. It's also Bazel to give the automotive touch where it came from, and this is used by the Elisa project, and we're in discussion with the kernel CI project that they also use this. You have graphical interface, you have command line interface, you can link it to different kind of test cases or to specification, to man pages and so on. So that's this tool. I don't tell much, you can read the docs for it. And the second one which I want to show is StrictDoc, because we were in this field of Linux world, Zephyr and Xen. StrictDoc is more something where you also write down all the requirements as docs as code part. You put things you can export and so on. And this is already developed with safety in mind. There is tool qualification ongoing, if I remember correctly, and Zephyr project use it mainly to document requirements and come to traceability. We talked about the Xen project. The Xen project already had a lot of work in the past, and they use OpenFastTrace because they had things documented. What they mainly needed was traceability, and that's where OpenFastTrace is good at. So therefore this is used by the Xen project. Again, you can read what it is all about, and these were 3 examples of open source requirements tools. There are more requirements tools out there. To give you some example, there's Doorstop, which is derived from the doors name of IBM Rational Doors, which some people may know. There's Swings Needs, which we use in the Eclipse SCORE project, for example. Nazar has some tools, and so on. So you have all the links there. You need to maybe find the tool which you like most. The things they have in common are mentioned here. They have docs as code. They are handled, requirements are becoming code. There's different types of code with YAML, restructured test, markdown, but it's basically machine pathable. There is the trace to source code and test in mind. There's a high degree of automation in mind, and I think this is something where the traditional requirements tools partially lack capabilities. You can have APIs, command line interface, scripting, and so on, because they're really CI/CD friendly. I made a summary by saying it's by engineers for engineers, and that's what we can really see. And this even, you see it on the right, Linux kernel requirements helps us to get into the Linux kernel. And yes, it's right, requirements within the Linux kernel. We're currently in the process of bringing the first things in. So there are identifiers considered following SPDX with ID and our text and so on descriptions. So, and as I said about maintainers, we need to make this and pick up the maintainers. So from the beginning, we're discussing with Linux kernel maintainers if it's adoptable, and we shouldn't increase any effort to the already loaded maintainers. So this is something which can be worked on by a community, can be added by experts, by users, and it's not a must, it's something which can go in step by step, as said, without increasing the maintainer load. How does this look like? It requires scripting, of course, and a way to easily handle. Where by talking to the maintainer, they told us it's important that it is directly in the code. So compared to some other parts where you write requirements as a YAML file, markdown, restructured text, here you directly will put this into the Linux kernel code base. And this will be an example here. You can see that there is an SPDX requirements ID, and then they're followed by a text. And then at the bottom, you can see the actual function call. Right. And the requirements shall be testable, maintainable, should be compatible with pre-existing kernel. That's why we also use the SPDX identifier, which is already accepted. And yeah, then the scripting, because you can see there it says to do automatically generate it. This means that there is something to check and create requirements, because then you can bring it again in your CI/CD flows, checking parts, whatever you like. So for this we have a script available which does this. It checks that the path is not changing, that the file name hasn't changed, and some other parts. So you have this in here. Right. As we come to the end of the considered presentation time, I come to the summary and the call to action. I made it very short. So the open source bot is inevitable in safety critical system. It's already used. We saw the different products where it's in. We saw that it's wider adopted. It needs to handle the complexity parts. You want to be fast, secure, and many different things which you already combine with open source software where you see the benefits. But especially for the safety space and also in general, communities must engage, companies must engage with communities now. So you need to have companies doing more work in the open, share their requirements, share their demands, bring in patches and so on. And they have access to standards. Companies know what the standards ask for. Open source community members may not have the standards at hand, so they don't know what is expected from them. And in order to help this shaping, join an initiative like ELISA to shape the future. Go to the Xen project, to the Zephyr project. They just show up. So we have, for all these projects, there are open workgroup meetings, there are Discord channels, Slack channels, Matrix channel. You can interact. The projects are really open, and you just show like ways of interaction. So you have mailing lists within the ELISA project. We have the meetings, as mentioned. The GitHub repositories are there. We also have working groups where you can participate, reach out. You can have direct documentation in the web, or also go to Discord. And with this, I want to thank you. Again, I am super happy that I can present this, and it's very unfortunate that I cannot make it in person. I hope to get in touch with many of you and hope to see the one or the other again. I will be in Japan in December for the Open Source Summit Japan, if someone of you considers it. I think there's still a few days left, or it could be close to the CFP date. But still, would be nice to see one of you. Connect on LinkedIn, join our mailing list, go on Discord, whatever possibility you have. And thank you so much. It was great.